of the solid that lies under z equals x squared plus y squared above z equals 0, and inside x squared plus y squared equals 2x. And so what we talked about last time was the fact that this was that paraboloid, right, facing up. I went ahead and traced down the red. And then what we have aside from that is above z equals 0, and inside x squared plus y squared equals 2x. It's that inside of x squared plus y squared plus equals 2x that tells us what exactly we're going to be integrating over. So this kind of gives us the idea of where that domain we're looking at. Now we talked about last time that in order to visualize this, because that's the first step whenever we do these integrals, right? In order to visualize that domain, we notice it's a circle. How do I know it's not a circle? How do I know it's a circle and not like an ellipse or something? That's a really good question. How do I know this is a circle? Yeah, it's just x squared and y squared, right? First of all, they're both added. If they were subtracted, what would I have? If they were subtracted, it'd be a hyperbola, right? Subtraction has hyperbola. In order for it to be an ellipse, there would have to be a coefficient other than 1. So like 1/2, 3, that would be what signaled I had an ellipse there. If they had coefficients and the coefficients were not the same. That's what's really going to tell me. Now we know this is a circle because once again they're both squared, same coefficient in front, added. So what we do first of all is figure out what the equation of that circle is. To do that, we move everything over to the left-hand side, and what did we do next? Completed the square, right? So to find the equation of the circle, we complete the square. So when we're going to complete the square, I'm going to go ahead, I'm going to add 1 on. The way I do that is I take that -2 divided by 2, square it, and add it back up, plus y squared equals, but unfortunately I'm not allowed to just add 1 to one side. What else do I have to do? Add it to the other side, right? 1, which gives me in total x minus 1 squared plus y squared equals 1, which is pretty fancy. So, what's the radius of my circle?
If it equals 0, we would have
Equals 0.
If we don't add 1 to the other side, we would get x minus 1 squared plus y squared equals 0.
You would also have algebra problems. You cannot add 1 to one side without the other. So despite the fact that it wouldn't make sense geometrically, don't do it. Okay. So we've got the circle that's radius 1, right? And it's centered at 1, 0. Now this is really important because in the past, all the polar coordinates we looked at, whenever we looked at these circles, they were centered at what? The origin, right? It's the fact that this isn't centered at the origin that makes our life a little bit difficult. So when I draw out this domain, I know once again the circle is centered at 1, 0, it's radius 1, so it's going to come around like that. I'll get our cookie ball. Okay, so I've got my little domain there. The next thing I need to do is talk about my bounds and converting. How do I know I want to do this in polar coordinates, first of all? That's exactly right. It's a circle, right? Because I can see it's a circle or a disk, I know I'm going to want to be doing polar coordinates. Which means I know that x is going to be r cosine theta, y is going to be r sine theta. All I really need is my bounds. Now, we need to think about this here. Let's talk about the bounds for theta to begin with. What quadrants am I running this in? 1 and 4, right? And because I'm in 1 and 4, what are my bounds? Where do I start? Negative pi over 2, and I go up to pi over 2, right? We talked about exactly why we have to do that last time. So these look like my bounds for theta, and the only other thing I have to do is find my bounds for r. Now, in the past, we would have said, well, it looks like we're running our radius from 0 to 1, right? Because 1's radius is a circle, 0 is the smallest the radius could be. That's not the case here, because polar coordinates only work like that if our circle is centered at the origin. If we ran it from 0 to 1, it would be calculating the circle that goes from 0 out to 1 and around. reason why we can't just put it from 0 to 1. Instead, we need to talk about, well, how does this radius look? Stretching from here, 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 and around. To find exactly what our bounds for R are going to be, what did you guys do on your homework? I plug in my X and my Y. What am I plugging them into? The equation of the circle. Now we need to think about this. I'm plugging them into the equation of the circle. Why does that make sense? I'm trying to find my bounds, right? What's the boundary? This is what I want to integrate, right? So the boundary is the circle going around. So what the boundary of this domain is, the actual boundary, is the circle, right? Now we can do either one. I'm going to write it like x minus 1 squared plus y squared equals 1. When I say either one, we could also do this original one if you wanted to instead. This is the boundary, right? Because I'm integrating from the inside of that circle all the way out. Well, if this is the boundary, all I need to do is solve this out, right? I want to find the boundary for R, so what I'm going to do is I'm going to go ahead and plug in here. We'll go ahead and say this is R cosine theta minus 1 squared plus R sine theta squared equals 1. I want to make sure you guys understand that this is pretty logical. I want to integrate on this domain. The boundary of it is the sides of the circle. This is the circle. To find my boundaries for the radius, all I need to do is solve it out for R. Now, I believe this is the way we probably did on our homework, right? Is there an easier way, maybe? Well, since there were two options, right? We can plug into that one. What other one should we plug into? The original one. Why might plugging it into that original one, I'll leave that, why might plugging into the original one be nicer? What is this left-hand side? R squared. R squared, right? Equals 2R cosine theta. Millions of times easier. It's way nicer, right? Can I divide an R off of either side? I can't make that assumption, right? That's really dangerous. So what I'm going to do is I'm going to move it over to the same side.
Actually, can't we make that assumption using our domain? We know that R really is 0 and 1.
But you just said to divide it off, you have to make the assumption that R is not equal to 0.
We know it's going to be 0, we can't divide it off, right?
Good questions. Okay, so what am I going to do with this junk right here? I moved it all over. Factor an R out, right? Now I have R minus 2 cosine theta equals 0, which gives me two options. Either R is equal to 0, or R is equal to 2 cosine theta, right? Which of these is going to be the smaller of my bounds? 0. Here in 0, what do you think? How can you guarantee that? I mean, cosine goes to negative. Such a fun question to ask. How? Well, between negative pi over 2 and pi over 2. I want you to think about this. Yeah, guys, can't you visualize the graph of 2 cosine at 8 in the morning after 3 seconds? Actually, you should be able to. So, cosine is like this, right? So between negative pi over 2 and positive pi over 2, it's positive, right? We're going to be good with this. So, that's how we know this is going to be our upper bound. If we were on different coordinates, if we might have been running from pi over 2 down to 3 pi over 2, it might change some stuff there. So, having all this, having the bounds, next thing I have to do is just set it up, right? When I set it up, I need to put something on the inside of the integral. Well, what function am I integrating? What's going on inside? Well, it's always whatever that upper surface is, right? Wherever I'm cutting off the volume. In this case, it's going to be my little red red shape there, which was what? And that's it, right? And then we're going to go ahead and I'm going to write this as dA. So right now I'm just in rectangular coordinates. I haven't swapped anything out. This is actually about to get really, really nice because when I swap this into polar coordinates, first of all, what bounds are going to go on my outside? Negative pi over 2 to pi over 2. That's exactly right. Negative pi over 2 to pi over 2. Theta is always my second one, right? And on the inside, I'll be integrating this from 0 to 2 cosine theta. What will I have on the inside of my integral? R squared, right? Because x squared plus y squared equals r squared. And, second, we're good. I always plug in, right? What else do I need? I need one more r, right? Because I convert it over. And so it's dr. Okay. I'm going to go ahead and rewrite it one more time. I'll go to this negative pi over 2 to pi over 2. 0 to 2 cosine theta, r cubed, dr theta. First integral going to be nice, or what do you think? Super easy, right? Power rule. We can totally do it. So, negative pi over 2, pi over 2. This is one of the few ones we're actually going to spend some time to evaluate. 1/4, that's like r to the 4th. 0 equals r. 2 cosine theta equals r d theta. Don't drop your differential. Even now it doesn't look bad, right? It doesn't look bad at all. I'm going to go ahead and evaluate this. Negative pi over 2 to pi over 2. 1/4. And when I plug this in here, I'll have 2 to the 4th, right? Everyone's okay with that? So it's going to be 16 cosine to the 4th. Theta. D theta. You're okay with the numbers I have? I'm going to go ahead and simplify it. Pull it down, negative pi over 2 to pi over 2. 4 cosine to the 4th theta, d theta, and we're actually talking about your guys' Calc 2 exam over this kind of stuff earlier. What do you kind of want to do with this? You kind of want to do a U sub, right? You're saying the 4th power. Can I do a U sub on this? I could do U equals cosine, but is du going to be there? No, right? We're screwed. Okay. Luckily for you guys, we know something about cosine to the 4th power. And that is, I know, I'm going to go ahead and rewrite this. Negative pi over 2, pi over 2. I'm going to pop that 4 out in front just to kind of get rid of it. I know cosine to the 4th is the same as cosine squared theta. What? Square. Now, it doesn't look like my life has improved at all, right? But it actually has, because what do I know about cosine squared of theta? You know something? What is that formula called? Power reduction, right? I know my power reduction formula. Power reduction formula for negative pi over 2, pi over 2, 1/2, right? And it'll be 1 plus cosine 2 theta squared d theta. Now, at this point, you are tired of writing your bounds and tired of carrying around your differential. It is totally okay to take this over on the side and work on it alone and then plug it back in. You want to work it on the side, it's okay. I say that because life's about to get a little bit tough for us. I'm going to go ahead and distribute the square in. When I say distribute the square in, I mean I'm going to square that 1/2 and then leave that there. Squaring the 1/2 will be 1/4, right? 1 plus cosine 2 theta squared d theta. Trying to write out all my steps so I don't lose anyone. Negative pi over 2 to pi over 2. That 1/4 and the 4 will go away, right? We're okay with that? What am I going to have to do, though?